welcome to RPGeeks, where science geeks roll dice and tell stories. We are 3 of the 4 RPGeeks. We are professional science communicators. We like playing tabletop role-playing games. And, as you'll see today, talking in a nerdy amount of depth about the science that's come up in the story so far. So thank you all for joining us. Thank you, Twitch viewers today.
Hey, Twitch. This is our first one that's live. All the episodes previously
live. It's true.
have been
pre-recorded. Oh my god, Twitch, you're still here.
Twitch, you get the advantage of live us. So pop your questions in chat. Hello also to the YouTube people of the future. Is it nice? How's the future? Let us know in the comments.
Who's Prime Minister? Let us know. Like it's
no.
Might be very different.
And hello, as always, to our lovely podcast listeners who we appreciate muchly.
I can touch you through your ear holes like this. There we go.
If you have been touched by Simon through your ear holes and you'd like to make a complaint, please email rpgeeksdnd@gmail.com.
Yeah, that's our HR department.
Feel free to send us your complaints about Simon's behaviour. Thank you very much. So today is a slightly different thing from usual. Today, we are doing our very first Science of Starfinder.
I was about to point out that I thought you were going to say today's a bit different. We don't really know what we're doing. We haven't done this before. I was like,
we're professionals.
That's every week. Every week we don't really know what we're
doing. Don't worry,
dive
everyone.
into the blue yonder. Is it blue?
Some of them are blue.
What yonder?
Are they?
Yeah, some of the yonders.
Is Uranus blue? And do we say Uranus or do we say Uranus?
My anus is no longer blue because
of
the treatment. But Uranus is kind of more of a grey, like desaturated blue.
Is it?
Yeah.
Wait, but also but the blue, blue that we see them as, right? Is that like false color blue?
No, that's real color. It's because of the compounds that make up the outside. So the reason that we'll get into this in more detail, but like the reason that
we'll get into this in more
the gas giants are kind of orangey yellowy is because they're made of the outside of them is hydrogen and helium. Whereas Uranus and Neptune are ice giants, they're made of ices. And so it's ammonia and methane. So they're different colours.
But I thought they were gas.
We'll get to that. We'll get to that.
But these are good facts that should come after I finish explaining what the heck's going on. Perhaps.
Andy, get back here right now. Sorry, I'm looking in Twitch chat. Andy is slacking off to go to the sauna in his hotel. Where are you going?
Andy's having a lovely holiday.
I'm in my
goddamn holiday. Listen, I'm bringing it back round. Right, what we're doing is we're doing the Science of Starfinder. So, if you have been watching our campaign, our new campaign, the Absalom Files, we have had 2 episodes so far, and we have picked from those 2 episodes 2 science topics that we've come across in the story. So basically what we're going to be doing is, next week we're diving back into the story, and then after a few more episodes, we'll have another Science of Starfinder episode. So, as the campaign is going along, if you think of scientific questions relevant to the stuff that happens, also let us know so that we can remember and include them in the Science of Starfinder, which is what we're doing today. Science. I feel like I need like some sort of
I feel like the thing which is going to take this to the next production value level is if we have an ongoing experiment, right? That runs from the beginning of this campaign to the very end, right? And it's something to do with Starfinder, and then we have a permacam on the experiment, right? Whatever it is.
You mean the literal experiment?
Like a pitch drop experiment or something, like something that takes a really long time.
Slowly.
What's a yeah, exactly. I was thinking something a bit darker, but pitch drop fine. And then we just kind of go back and we revisit, and that's Science of Starfinder happening in front of our eye holes.
What if we launched a satellite or something? Like, let's just dream big.
And what?
Or start of the stream, we do an episode on atmospheric composition, and we launch a weather balloon with a GoPro on it
as it's going through,
and then we live stream.
Fucking good.
That is actually quite a good idea.
Did you guys see that's a good idea.
Yeah,
did you see the Thomas the Tank Engine, like the weather balloon Thomas the Tank Engine video? Where they send Oh, it's the sweetest thing in the world. Like it's a dad whose little kid plays the Thomas Tank Engine and it like wants it to fly and stuff. So the dad attaches it to a weather balloon, sticks a GoPro on the side of it, and sends it up, right? And it plays this really sweet music and it goes all the way up into the atmosphere in a burst and then falls back down again, and then they go find it. It's beautiful.
See, Tom Scott did a video, and it might be his most popular video ever, which is "We sent garlic bread to the edge of space and ate it," where he just put garlic bread on a weather balloon.
Good title. Like it's like that's good, though, isn't
It's
it?
so good. Like it has like
so
over
good.
10 million views. Let me find this right. 61 million views.
Oh.
And it's like, no notes. Why didn't I think of this? Like, this is my thing.
We sent
You've
garlic
thought
bread
of
to the
the nerdily educational one where you just talk about things, but there's no garlic bread. So
Yeah,
you've got ideas
garlic bread
too.
makes everything better.
They're just not as good.
Let me put it like this. He's got a video that's 2.5 hours of unedited footage of this ascent and descent, and it's got 7.3 million views.
Wow.
The AdSense. This is where we're missing out.
Yeah.
I am curious if that's his most viewed video ever. Actually, I'm just don't mind me, Shamini. If you want to take back over after I've completely derailed this.
I can't remember which order we said we'd go in because I wanted to like introduce the topic.
Oh, sure.
I feel like Calamity
can't
Gas is
remember who's
talking
going
about
first.
garlic bread edging, which is something else. But
Anyway.
Oh, there's so many different ways that could. Yeah, let's not go down there.
So there are two topics. Oh, I know what I'll say. I will say you'll know what our topics are for today if you're watching this because it's in the title. So actually that's less of a surprise. But also because we picked them on our Patreon behind the screens bonus content that we do for the shows. Massive big I wasn't planning this, but massive big thanks to our patrons. Aaron, Cass, Will, Cameron J, Nick.
I don't have access to
Andy!
the back end at the moment, so I actually can't look.
They got a preview of our topics today.
wait. Tell me them again. I can tell you. I
got it right. Oh,
I think she got it with 6 of them.
I just did it in the wrong order because Andy should have been back to full.
Sorry, I thought I was going to jump in there as guardian of the Patreon.
No,
The Heimdall of our.
I am the.
patron.
Wait, isn't he the guy with the Bifrost?
Yeah, the guy with the Bifrost. You're the one who's like, permitting
I am
entry
that
or
guy,
not.
yes!
I see
Every
all.
time you enter our Patreon, you'll see me doing this. That's what you see when you
Podcast
come in.
listeners, there was some sort of a mime there that I cannot describe.
That was a sword. Believe it or not, viewers, that was meant to be a sword. Yeah, you have to sound like Idris Elba whilst you're doing it as well.
And there's the sound of someone just licking some garlic bread in the background. It's gross.
Oh my god. So wait, remind me who is going first.
I will go for. I'll take the ring to Mordor.
Okay. So, right.
Yeah.
Shall I do a little plot summary for our first topic, or have you got that sort of?
Go for it. Give me a summary if you like, because I've got a page open that's relevant to the science, but not one relevant to the plot.
Okay, great. So that everyone is aware, if you're watching the Science of Starfinder episodes, there will probably be spoilers for the campaign because we probably won't be able to resist jabbering on about everything that's happened, and it's quite relevant. But not the other way around. If you're watching the Science of Starfinder, if you're watching the campaign, there's no spoilers for the science. Can you spoil the science? Probably not. So that's fine.
That's preprint.
It's there's no pre-printing going on apart from the things that happened.
If you want to spoil the science, go to X-Archive.
Just be aware it's not peer reviewed.
Yeah.
What happened in episode 2 was our party went to somewhere that is a part of the Starfinder canon called Fogtown. Emily Bates has lots of descriptions, and as the Fate Weaver has all the sort of proper ways of introducing
Should we
Fogtown.
explain why Emily Bates has turned into a giant dice with a ring system, by the way, on the stream?
Yeah, Emily Bates. What's happened? Also, why is she still the Fate Weaver when we're not? Oh no, we're all still our characters.
Oh, the
we don't
dice
have,
itself is the Fate
separate,
Weaver.
A separate overlay for the Science of Starfinder, so we are all still.
Oh, we will.
We will. We will have to make that. This is. I've had a time over the past week or so. Let me put it like that. It's been very busy.
I wonder whether we could time over the past week or so.
Yeah, this is a lot going on. But yeah, she's busy. She's got an actual job.
She's so cool. She's so cool with a cool job. She's nailing it. She's doing so well.
Bird watching. Looking at all those birds.
You've got to get looked at. Apparently. Did you know if they're there or not?
Beats last year when she was looking at beaver.
I liked the beavers.
More than one beaver.
Plural.
Beaver cam was great, to be fair. Like when they had that little
beaver cam.
The wetland, and then you'd be like, oh look, here's a beaver.
Simon, you're doing things I know you're doing.
What? So... We had beaver cam last year. Do you remember when she sent those really exciting messages?
Beaver cam.
Wet beaver cam.
I know. Yeah. Okay.
This year she sent us a pair of great tits.
So Fogtown, huh? It's in the books. It's an official thing. So in Starfinder, on a space station, there is an area where you have to wear a gas mask to go into because it's designed for the alien races. But are you still laughing?
I'm so sorry. It's been like 10 minutes and it's completely derailed.
Nothing.
Emily Bates is working on Springwatch. For people who don't get the jokes that we were just making, just to be absolutely clear, she's doing media for Springwatch, so she's looking at birds, small British birds. Okay, let's try and claw some kind of respectability back for this show.
Shamini, I feel like this is on you.
Respectability the whole time. Like I'm not the one with a respectability problem here. Okay,
entirely fair.
Fogtown is designed for people, aliens. Species.
They're people.
Yeah, like specifically species that have evolved to live on, don't really know how that's going to work, gas giants. So I already, just from this starting concept of here, wear this gas mask because you can't breathe it because this is the atmosphere of a gas giant. I have many questions about the atmosphere of gas giants, how you recreate it on a space station, what's going on with these hypothetical alien species, and it's an atmospheric physics story basically. So look, it's Dr. Simon Clark. He has a PhD. Simon, what's your PhD on?
Atmospheric physics, not of gas giants. It's got to be said, it's not exactly perfect.
Yeah. And what have you written a book on?
I wrote a book on the history of atmospheric physics.
Hey. So I'm expecting you to be able to answer all of my questions today.
So I've got some interesting. I went down a few rabbit holes when I was researching this, right? So I'm going to read you the. I believe this is from the rulebook, the description of Fogtown. The neighborhood takes its name from the thick, multicolored atmosphere tailored to the natives of the gas giant worlds Brethada and Liavara. I'm probably pronouncing that wrong. Nevertheless, other species visit frequently, making use of communal breathing masks in the airlocks in order to interact with representatives from the various biotech companies or negotiate for gas mining or research rights. So
I didn't realize that the breathing masks were communal. Like, as in, it's just one big sort of trough that you kind of like.
Oh, that's horrible.
Like 5 other people. Yeah, that's really gross.
That's a COVID super spreader mask right there. Like, respiratory diseases are everywhere in Fogtown.
Question.
Yeah. Yes, the orangutan in the front row.
Stuff which is airborne, spread airborne. Could that be a kind of life that would exist naturally on?
Right. We'll get. Let me circle back to that thought in just a moment.
Like COVID.
So there's a few things that stand out from here, right? Like it says that the atmosphere is thick and it's multicolored. And specifically, it talks about gas giants. So you've got Brethada, which is blue and purple, and is a gas giant and has lots of moons, just like the gas giants in our solar system. And then we've got Liavara, which is the closest gas giant to the sun, and multiple layers of gaseous atmospheres, each densely filled with a variety of life. Doesn't actually specify its color, I don't think. Orange tinged. Okay, right. So
this is important.
This is important because
it's going to be relevant.
There are 2 kinds of giant planets that we have in our solar system, right? We have gas giants, but we also have ice giants. Up until the mid-90s, they were kind of lumped in together, but they are actually very different because Jupiter and Saturn in our solar system they're primarily made of molecular hydrogen and helium. And that's where they get their color from. That's why they're both similarly yellowy, orangey kind of color. Is
that like the same composition as what a star would be?
Yes. So gas giants like Jupiter, for example, is on the verge of being a brown dwarf, which is a failed star, basically.
No.
Like I can't remember the exact number, but if it was slightly bigger, it would have enough gravitational force to ignite a certain level of fusion.
No way.
So it's
cool.
kind of a failed star because Jupiter's enormous.
It's mean. It took a different path. It's not failed. It's just
yeah.
its own thing. Okay, Jupiter, you're fine.
It's I really shouldn't be using the conventional terms in the science literature because they're harmful.
Harmful to Jupiter.
I just want to, I don't know if this go way off the tracks, but like you say color, right? But color's a reflection of light. So we're talking about reflected light from the sun bouncing off Jupiter towards us.
Yeah.
And are we talking about like the way that light just reflects off these molecules, or are we talking about the light hits the molecules and excites them in some way and then they release a different kind of wavelength back?
So that will happen at certain wavelengths. I think in the visible it doesn't happen. I think it is purely reflected light, but it's also scattered light. Because the thing about, well, Jupiter is the sort of most famous example of this, is you can see clouds. You can see high-level clouds in the top layer of Jupiter's atmosphere, and it's got, I think it's 17 cells in its atmosphere. So the Earth has 3 cells, the Hadley cell, the Ferrel cell, and the polar cell, which are these overturning circulations, where air on Earth rises at the equator, moves towards the poles, and then it sinks again, and you get this closed loop. Whereas Jupiter has about 17 in each hemisphere, I believe.
So all different sort of loops going.
Yeah, all different loops. And so you see these bands of different colours, and the lighter colours are clouds. And they're clouds not of water, but I actually did have the notes on their composition. I think it's methane clouds at the top of Jupiter, but I could be wrong. That's not something I have straight in front of me. Yes, Ali.
So clouds can be seeded, right? Around particles. So are there is there particulate matter bigger than molecules in the atmosphere of Jupiter around which these clouds are seeded?
That's a very good question. I'm not sure about what the nucleation sites are. Presumably there must be something. I'm not 100% sure actually. Good question.
Note that down.
Write that down. If someone wants to go and research this whilst I talk about the rest of this.
Nucleation sites.
Nucleation. I'm going to look that up right now.
Yeah.
That'll be my job. I'll look that up.
So the top of Jupiter and Saturn, you've the clouds are formed of NH3, which is ammonium. Sorry, ammonia. There is a difference, isn't there? I'm not a chemist, but even I know there's a difference between ammonium and ammonia.
Saturn. Right. Okay.
And so
One's the ion.
Those are scattering light off of them, which is why they appear brighter. And so Jupiter has lots of bands, like I say. Saturn also has it, they're just less obvious. There was this article, it's a textbook chapter that I was reading earlier, which can I find the quote again? It basically described it as, here you go, Saturn shows similar but much more subdued cloud activity. Instead of vivid colours, its cloud have a nearly uniform butterscotch hue. I love the idea of turning up to the butterscotch planet.
Butterscotch planet.
That's quite fun. But
or just a guy called Butterscotch Hugh who just welcomes you in.
Like Jimmy Space, inventor of the Space Marines. Like, you get to name it if you're the person that discovers it. So Jupiter and Saturn are quite similar. They're both made of similar kind of stuff. Whereas Uranus and Neptune are not made primarily of hydrogen and helium. They're made of ices of things like methane and ammonium. It's ammonia. God damn it, I'm confusing myself now. Ammonia. And you get, there's a certain stratification, like you find the clouds of different chemical species at different heights within the atmosphere. But that's basically why the top layer of them is a different kind of cloud. I'm just going to get the note up in front of me. Yeah, they have hydrocarbon ices as their top level. So, stuff that has C and H in, like, for example, methane as their top level clouds. And that's why they are mostly blue rather than the other butterscotch of gas giants.
Oh, no, I have too many questions. One question is, so obviously Uranus and Neptune are further out than Jupiter and Saturn. But presumably they're not just the frozen ones because they're further away from the sun, because they've actually got completely different composition. But then that also leads me to question whether that difference in composition is, in fact, not a coincidence.
I believe it's mass fractionation in the formation of the solar system. So you get the lighter stuff nearer and the heavier stuff further out. So
is that as things get flung round and round, like in a centrifuge, heavier things move?
I don't have a source for that in front of me, but I believe that is why you get that.
It's not a coincidence anyway. As the solar system formed, different materials kind of went to different sort of distances, and hence those planets.
Yeah, exactly.
Cool.
Ali.
I'm back from science.
Oh,
right.
Go for it.
So I found. I'm just going to caveat this. I found a paper, right, which does cite other papers.
Things that are just a paper. Like all of your best stuff.
All of my things is just
guys, I found
paper.
this one paper.
That's the best kind. Someone who did that one thing. Like, was it represented? Doesn't matter. No. So what they're saying is that it has been assumed that cloud formation processes for brown dwarf atmospheres, so something similar to what Jupiter is typically assumed to begin with the formation of titanium oxide seed particles in the upper atmosphere.
Isn't that the same as ours? Does that sound familiar? Titanium oxide?
That's one of the proposed things that you could use for solar radiation management.
Oh, right.
You could eject it into the atmosphere and make the Earth more reflective. Okay, cool.
What's titanium oxide doing in the atmosphere?
Does not go into that in this one paper.
That beats me, because I'm looking at the composition of the atmospheres and it's not listed in Jupiter, Saturn, or any of them.
I suppose it could be so tiny that it's not listed, but then if it's so important.
Maybe. I'd have to look into. That's a very interesting question. I don't really know.
What's Jupiter atmosphere?
The one
maybe it might just be a modeling framework where they're like, this could give you the clouds that you see.
Yeah. Maybe.
Rather than actual observation of it.
So there was an interesting thing which I came across, which I didn't know about in researching this, which is that these gas giants, and I can't remember which one it is. I think it might be Neptune, or I think it's Neptune. It might be Uranus. It's one of the ice giants. Radiate more energy out than they get from the sun, which is weird, because those should be in balance, because that's what defines radiative balance. That
the core.
Defines...
What about the core?
Yeah. Okay.
The core.
Leftover molten core
Produces what's called Kelvin-Helmholtz heating. So this is where the gases are so compressed.
This is my friend Kelvin Helmholtz. He's the butterscotch guy. Anyway,
they're so compressed
that
they basically produce a outward pressure that then produces this radiation. So thermal energy comes from, in the same way that if you compact certain materials on Earth, they heat up. But if you do it on large enough scale, then they can give off thermal energy.
Radiation.
So even though they don't have a solid core, I mean, I think we're not sure.
They don't have a solid core.
Okay, I'm going to have to double check this now, because I think that we don't
just like
know
soup
for sure.
In there?
I think it's basically So at the center of Jupiter, at least, there's metallic hydrogen as a core. So the hydrogen gets so compressed that it starts acting as a pseudo metal, and so it actually becomes like a solid lump of hydrogen at the insanely high pressures in the middle. The other ones may have a sort of a core. I mean, a lot of this is speculative, right? We've never been to the center of these planets, but at any rate, the way that
have we never sent? Sorry, surely we could just shoot something into the center of these planets. Why does it not, get there?
It won't last very long, is it?
Because they're huge.
Well, why not?
I mean, hang on, what's the radius of Jupiter? Let me find that.
It's made it all the way to Jupiter. Well, I mean, all I'm saying is, like, if it just got to go through gas to get there, why can't it just plow on through and then be like?
Because you've got, I mean, the pressure, I don't know off the top of my head what the pressure is within a few kilometers. I'll come back to that point in just a second, actually. But consider that Jupiter's radius is 70,000 kilometers. So it's a huge amount of pressure.
How far is that?
I mean, the Earth's radius is 6,400 kilometers. So it's an order of magnitude bigger than the Earth. And you're plowing straight through tens of thousands of kilometers in order to get to the center. So good luck getting there, but also good luck getting a signal out back to Earth.
Yeah. I feel like a real div about this now, but I'm going to ask it anyway in front of people. I don't understand the pressure thing. Like, surely if it's at high enough pressure to, I don't know, crack metal, then, it's at high enough pressures to form like a liquid or form a solid or something. Is that just done?
Well, so that's what happens in that metallic core of the gas giants. Like that is what happens. Truthfully, I don't know if there are other layers around that, and I'm not sure if science knows that there are other layers around it. I'm sure there are probably models of this, but it's not to my knowledge do you get other solidified layers of other materials besides hydrogen in the cores. But I got myself distracted there. So basically, you've got this atmosphere in which everything's at the very top. It's obviously quite warm, even though there's a weird temperature gradient thing because you're heated from below by this Kelvin-Helmholtz heating, but you're also heated from above by atmospheric radiation ionizing the top layer of the atmosphere. That's what happens on Earth. But the further down you go, and you go down for tens of thousands of kilometers, it's more akin to oceanic life than it would be to atmospheric life, because it's like being in the deep parts of the ocean, over the continental, away from the continental shelf, where there is no bottom and there's no end.
Is it liquid?
It's not so much that it's a liquid, but it's more that the energy source in your ecosystem is exclusively coming from up top. Like, there isn't an energy source that's going to be coming from below in the same way that it would in the atmosphere.
So okay. So on Earth, or most of the energy primarily comes from the sun. So if you're a deep sea creature, you just need sun food creatures to fall down upon you.
Yeah.
Or vents.
Or hydrothermal vents.
Hydrothermal vents, but you don't get those in Jupiter. That's the idea, right?
Yeah. So I was sort of came at this problem. I was like, right, could life evolve on one of these planets? Because that's ultimately what we're trying to get to. There are lots of species that are described.
Yeah.
And they're these floaty type things. And like, kind of the question is, how could life initially develop on one of these things? And if you want to create life, you've got to create amino acids. I'm not a biologist, but I know that much.
If you want to create our kind of life.
Sorry, yeah. This is the whole...
Can we imagine different kinds
the comet.
Yeah.
That's the comet seeding hypothesis, isn't it? Like,
well, it's one of the ways that it could have happened.
Yeah.
Because this is the idea that, like, you are a scientist who's dropped their keys on the street, and you start looking under where the lamp is illuminating it. It's at night. And you don't necessarily think that your keys were dropped there, but that's the bit you can see, so you search there first. And then you start touching around in the dark. So
hypothetically, if we're talking about amino acid based life like we have,
yeah,
could that evolve in a soupy gas giant atmosphere that's kind of like the deep sea?
Yeah. And so what do you need to form amino acids? You need, I don't know, Ali, do you want to answer this?
You need water, for fuck's sakes, because you need specifically you need the kind of the way that water allows you to form those kind of, that water has a dipole structure, so it allows you to do kind of funky stuff in terms of like forming different kinds of bonds and things and shaping the molecules. So specifically for amino acids, that's what you need.
Is this like the same as hydrogen bonding, whereas water has really unique properties because of hydrogen bonding?
Yeah, it's basically it's got a polar shape.
121 degrees or whatever it is.
I don't know, but it's a Mickey Mouse, right? So like the oxygen on one side and the two hydrogens on the other.
Yeah.
But I don't think that. Well, I know ammonia is NH3. Is that right?
Yeah.
So in a way, that is polar. So maybe there's a way.
Well, the one experiment that everybody talks about within this field is the Urey-Miller experiment, right? So it's like this was the experiment that they did in the I didn't actually get the year of this. When was it? 1952, where they tried to recreate the conditions on early Earth, which was this kind of soupy atmosphere that had in it water, methane, ammonia, and hydrogen. And then they stimulated that within a closed environment with an electrical spark. And they found, after running it for, I know that it was a long time, but I can't remember. It doesn't say actually on here exactly how long it was. But they basically sparked to simulate lightning for a long period of time, and then they analysed what compounds they got out at the end of it. And they found that they'd actually created most of 11 of the 20 basic amino acids. So that's this hypothesis that basically
spontaneously
all of this, the primordial soup in the Earth's atmosphere was the right combination of elements, of compounds, and then an electrical charge to provide some energy input, and that produced the building blocks of proteins and so life. Yes.
So you said that we were saying that the only way of getting energy into the system would be from the sun, right? But Jupiter does have a shitload of storms, right, going on.
Yeah, we see atmospheric lightning.
If you have rubbing together stuff and you're generating lightning, then that's another way of bringing energy into the system from just the kinetic force of all the stuff moving around.
Yeah, and this is the other thing, like, because of these big overturning circulations, there's lots of vertical movement in these atmospheres, so you do get charge building up and you do get lightning being observed. So that's absolutely taken care of. I mean, if you go through the list of things in the experiment that they had lightning, which we've got. They had ammonia, which we have. Methane, which we have. And hydrogen, which we definitely have on a gas giant. The one thing that is lacking in both gas giants and ice giants is the the water part of it. Like on Jupiter and Saturn, you've got a few parts per billion of the atmosphere being water, and on Uranus and Neptune, it just says 0. Like we've not detected any evidence of it.
It's all frozen methane, is that right?
Yeah, I would expect that all the hydrogen and oxygen is just bound up in other stuff, and also because it's oxygen, I don't know if you get it that far out. I don't know if that's another mass fractionation thing.
But hold up here, so-called Dr. Simon. I know that comets are full of water because that's their thing. So what if a comet smashes into the old Jupiter? Doesn't that bring in some water? That water's not going anywhere.
Yeah, some water can be brought in. I think the thing to remember is that these planets are so much bigger than Earth. Like we're talking an order of magnitude bigger than Earth's atmosphere. And yes, Earth possibly inherited a lot of water from comets, but we are in a different part of the solar system. There was this period, oh gosh, when was it? 1.6 billion years ago? There was something called the Late Heavy Bombardment, where all the terrestrial planets just had a shitload of stuff thrown at them, which probably included a lot of water. And maybe that's actually where the stuff came from on Jupiter and possibly Saturn, but seemingly we have not detected evidence of water in the atmospheres of Uranus and Neptune. So from that perspective,
that like we often talk about like carbon-based life as opposed to silicon-based life, but in another way we are very much water-based life. Like it's so vital to filling our cells and having the right construction of them.
There's a great YouTube channel who's just kind of popped off recently called A. Collier Astro. I can't remember her first name off the top of my head, but she did a video on, she's an astrophysics PhD grad, and she did a video on the aliens will not be silicon, and why carbon-based life is just so much more likely than silicon-based life, which was to do with basically how silicon interacts. I think it was the geological cycle, but also how reactive it is, and that carbon is just always more reactive, which is why we're carbon-based life forms.
Somebody bring me a periodic table. I'm going dark.
So is like amino acid based life on gas giant doomed without water? What if there's a really watery gas giant?
It's possible that you could get a bunch of water in the gas giant. So I think, it's one of these things that's like, we haven't observed it, but it doesn't mean it's impossible. And the other thing is that, everything I've said so far sort of indicates that, we don't expect life to have evolved on these planets. However, we also didn't think that there'd be life at the bottom of the ocean when we first started exploring that in the late 19th century. And we drew up samples and found, holy shit, there's like worms and stuff in this mud. How on earth is that possible? So biology is one of these fields that is incredibly difficult to predict.
Biology, yeah.
Can I jump in and just offer? Yeah, I'm gonna do it. Get out of the way.
Sure.
So, but also, like, you've got to check your definition of life, right? Like, I mean, we were taught Mrs. Gren in school, right? So movement, respiration, sensitivity, growth, reproduction, excretion, and
Norman. So Mrs. N. Nutrition.
I don't think that's right.
I'm not sure.
Someone in chat will correct us, I'm sure.
Anyway, but if you want to go deep, you could say that really the only true definition of living things is something that reproduces itself. And
I'm happy to include viruses in the happy family.
But it's prions, right? A prion technically would be alive by that definition.
I forgot I had to.
There's lots.
By that definition, are computer viruses alive?
Oh damn it!
Yes, by that definition, they won't be alive. But it depends on what milieu you're talking about. Like computer viruses, it's not a physical thing reproducing itself. It's a set of code. So it's information.
That's DNA. Surely that's a genetic code.
But DNA is a physical object that reproduces itself in shape, rather than a computer virus, which doesn't do that. Unless maybe you're talking about the configuration of the electron gates within the chip. But anyway, so what I'm saying is, right, you could have stuff on those planets, like formations of things which seed themselves, so the whole thing becomes full of these things, but that don't show any of the other kind of things that we classically call living, like sensation or anything.
This sounds like a problem for either a philosopher or a biologist, of which I am neither.
What about a philosophologist? Yeah,
the people who did physics and philosophy terrified me at Oxford. I don't know how your brain can do both of those subjects at the same time. So like Yeah, everything seems to indicate that like the actual evolution of basic life forms certainly hasn't happened in our solar system, and it's unlikely to happen in other gas or ice giants. Because that was the thing I was wondering. I was like, actually, it sounds like because of the availability of things like, radicals like ammonia and methane, they're much more prevalent on ice giants. And so maybe it would be more likely that you get life on one of these. Seemingly not. One of the reasons for that is that it would be airborne, for one thing, and possibly it would exist in, droplet form, or it would be one of these floating type life forms, which is one of the life forms that
or a fishy. Could it be a fishy?
Yeah, it could be,
Yes.
like with sort of sail fins and things like that. Like, that's the kind of design that you see in Starfinder. I can't remember the name of the species off the top of my head. But yeah, those are the kind of things that they have in Starfinder. And also Carl Sagan, there's a bit of Cosmos, which I watched, where he actually talks about this and has these hypothesized creatures that were like, I think he called them floaters and sinkers, which is slang that's been unfortunately reappropriated since to describe turds. But like, that's how he thought about these things. The one thing that I would say from an atmospheric dynamics point of view that makes that unlikely to me is that on ice giants, you get the fastest winds in the solar system. Like Neptune's winds at the equator are about 2,000 kilometers per hour. Like, I think they're actually supersonic.
Wait, why are they so fast?
Right. So I think it's basically the fact that you've got no land underneath, so there's no friction, and you've got a huge thermal gradient that builds up.
I thought Neptune's solid.
Well, no, it's made of ices, but it doesn't have. Hang on, let me get the.
I thought ice was solid. I thought that was one of the defining features of ice.
No, but it's like but it's ices at different pressures, right? Like if you have ice at a higher pressure, then it's not necessarily solid.
What?
Hang on.
Wait a second.
Simon, what's happening?
This is blowing my mind.
But also, ices means something a little bit different. Like I had to get this up. Let me read you the wiki. Ices refers to volatile chemical compounds with freezing points above about 100 Kelvin, such as water, ammonia, or methane, with freezing points of 273, 195, and 91K respectively. So they don't have solid surfaces. It's just that we call the things that make them up ices. It's like a.
Oh. So they are also gas giants.
Yeah, but
that's
like
why we're talking about them.
Because they are made of ices rather than molecular hydrogen and helium, we call them something slightly different. I mean, it's one of these things.
What do we call them? What are they called?
They're called ice giants.
Ice giants. Oh, right.
That is the term that we use now. Interestingly, sorry, I'm just reading this off the page now. Gas giant was only coined in 1952.
What were they called before that?
I don't know.
Planets. We were all just a happy family of planets. Pluto was one of us. Like, we were all just together before all this division started.
We just went into naming things. It was like, yeah, they're big, but I don't want to name it.
We're not into categories around here. It's kind of like a humanities department. It's all just blurs into one.
Yeah, exactly. Like, it's restrictive.
So, sorry, that slightly blew my mind that term is so modern. But yeah, basically you have a very large thermal gradient. There's no friction at the bottom, and they do spin faster than Earth. So you've got a very strong Coriolis deflection. So you get these jets that are really, really fast. And so if you were airborne, you'd have to survive like potentially supersonic winds, which
isn't. But that's Neptune and Saturn, though, right?
That's Neptune and Uranus. I don't have the figures to hand of the wind speed at the top of the other.
If that was a constant wind speed, then if you just evolved to live in, if you just, like you essentially would be going at nil speed, right? If you were basically just at that speed all the time. Do you know what I'm saying?
With it.
Yeah, I mean
everything's moving around you.
And yeah, this comes down to like we're looking for life that looks like life that we're used to, right? And so when we're thinking of life that's suspended in a medium and has energy coming in from the top, we think of oceanic life. And when we think of oceanic life, we think of quite fragile stuff that just floats around, on ocean currents, which are no more than, meters per second at most. So if it exists, it's going to be something that's very different and possibly built of something very different than what we have seen life on Earth. Sorry, I've nearly went into a David Attenborough voice then. So nearly different from life that we've seen here on Earth. But it's not to say it's impossible. And I suppose it doesn't do us any harm to imagine that the planets in the pack worlds could exist in this form.
I think what's
You ready?
Okay. Are you sure?
Yes.
I think I'm going in a different direction, but you just pull me back if this is the place we want to be. Okay. Well, I'm just thinking that. So actually, like one of the key things about the generation of life is the generation of the membrane, because that allows you to have
inside.
Yeah, allows you to put exactly and to change what's
gradient
inside compared to what's outside without it all just sort of mixing up again, which allows you to build up, all the different kind of like stock.
You can store energy and then release
exactly,
it
and then you can use that
membrane.
energy to build more complicated stuff, and then you can protect that stuff, and you have to have a membrane.
We're a membrane-based life.
Exactly.
Well,
so that's a sort of, but which makes you think kind of more on a bigger scale about the boundary between gaseous life. Like, yes, stuff which has a membrane like a jellyfish and floats on gas, fine. But stuff which is gas, how can it separate itself from other gas stuff?
Because there's always gas aliens in like Star Trek and stuff.
Like, how do they?
Gaseous life forms. Yeah.
I don't know. I mean, this is now verging into more of a biology question than a physics question, which I'm uniquely unqualified to answer.
I want to bring it round back to, we went to Fogtown on Absalom Station, or at least our characters did.
Yes.
Okay, hypothetically, we've got gas giant life, and presumably there's some kind of swimming, floating things, not water-based. My question is, so Fogtown, I think, was described as like recreating this atmosphere. And I can imagine that you could quite easily recreate the proportions of different compounds in an atmosphere. What would the pressures be like?
Yeah, it would depend on where in the atmospheric column the life evolved, right? Like, because it could be at about atmospheric pressure, which wouldn't be terribly deep.
Does that exist in Jupiter? Like, is the outside of Jupiter?
Yeah, well, if you think about any atmosphere, the pressure at any level in the atmosphere is nothing more than the weight of all the gas above it. So starting at the top of any atmosphere, you've got zero pressure, and then the further down you go, the higher the pressure gets. So at some point in the top of all of these planets' atmospheres, you are going to get one atmosphere, 10 to the 5 pascals. That is what we have here at the surface of Earth. What the temperature would be there, I don't know off the top of my head, but I would guess pretty cold. Because admittedly, on the top of the, it would be further into the gas giants, because you're dealing with hydrogen, which is lighter than nitrogen. So, Earth's atmosphere is basically nitrogen with a healthy dollop of oxygen. And so you would have to go further down than the depth of the Earth's atmosphere, which is approximately 100 kilometers, maybe 150 kilometers into Jupiter, but it's still going to be pretty cold.
So right now I'm feeling the pressure on my skin, on my body, of basically all of the atmosphere above me, which is whatever, mostly.
Yeah. Every square meter of Earth has 10,000 kilograms of air above it.
Oh, but if I was on Jupiter, I'm swimming through Jupiter, it's a really light atmosphere, so I'd have to swim really, really far down to feel that same pressure on my body and not explode.
And the temperature there would probably be quite cold, because the heat source, you got that Kelvin-Helmholtz heating coming up from the center of the planet, but that's 60,000 kilometers that way. Would it be all soupy like we imagine Fogtown to be? Would it be like, I can't see the sun because I'm so deep down in the soup of? Or would it be not that thick because it's just hydrogen at atmospheric pressure, so it's not actually liquid? Well, the clouds are pretty significant. You would see, if you've got clouds there, then that's something that would be visible. When you recreate the temperature and the pressure, so yeah, the clouds would exist in that form. I think you could depict it as anything from being almost entirely clear to being pretty hazy. Like, this is definitely where like sci-fi artistic license. You can hand wave and be like, oh yeah, it's pretty foggy in Fogtown today.
Fogtown was hot when we went there, because like we imagine Jupiter like as being red and gassy and burny, and I
sort of imagine it being kind of temperate.
Do you?
Yeah.
Well, Jupiter or Fogtown?
No, Jupiter. I sort of imagine it being a little bit kind of like tropical, a bit humid.
Can I find Jupiter temperature profile? Let's have a look.
It's red.
A storm thing.
It's enhances the planets. It's like the bringing of war. It's like the.
That's Mars.
Fiery... Oh yeah, what's Jupiter?
Okay, so
just thunderbolts and shit.
King of the other gods.
Yeah.
At one atmospheric pressure.
Just facts.
Good song though.
I'm reading into this. Oh, interesting. Okay. Right. So Jupiter has a very hot outer atmosphere, same as Earth, because it's where there's not very much gas, but what is there is being blasted by the sun, and so it ionizes, and so the few molecules that are there are moving around loads. So we say that means it's hot because that's temperature definition. So the temperature shoots down once you get out of the ionosphere, that part of the atmosphere. Then it starts decreasing. The temperature starts increasing again. Once you get down to about 1,000 kilometers from the really outer edges of Jupiter's atmosphere, which isn't insane compared to the Earth. The Earth's exosphere is about 10,000 kilometers tall, so that's roughly the right order of magnitude. Once you get about 1,000 kilometers down, you get to 1 atmospheric pressure, 1 bar, at which point it is approximately minus 100 degrees Celsius, so about 200-ish Kelvin, give or take. So it's pretty cold.
Chaotic in chat has a question that I might be misinterpreting. They say if you have more molecules, wouldn't that increase scattering and therefore cloudiness? This is again sort of talking about the visuals of it. Is there more? Are there more molecules of hydrogen, helium in the atmosphere than there would be in our atmosphere? What does that depend on?
So hang on. I'll tell you what, this is a cool learning opportunity. So you get the density of the atmosphere. You can relate the density of the atmosphere to the pressure and the temperature of the atmosphere by the ideal gas equation.
Oh, no.
So the pressure is equal to the density times the gas constant, the specific gas constant for whatever gas you're talking about, multiplied by the temperature. So the density is the pressure divided by the gas constant and the temperature. So depending on what the gas
somebody's face just double that
the
reverse equation.
Trying to imagine like D equals P.
So P equals rho RT, rho equals P over RT.
What's rho?
Rho is the density. So if you want to know the density of the atmosphere,
D?
Oh, it's just tell you what, this is a real bugbear of mine. In atmospheric physics, we use P for pressure and rho for density when those two letters are almost the same, and it drives me nuts.
That's not good.
So if you had a pressure of 1 bar, then hang on, let's see if I can do this on the fly. So what's the hang on, we need the specific gas constant for hydrogen. So the specific gas constant.
Hydrogen. There's a bit of ammonia in there.
There is, but let's do first approximation here. So the gas constant is approximately 4, which is roughly half of what it is on Earth. So if we have 10 to the 5 divided by 4 times, I said it was about 200 Kelvin, then the density of the atmosphere is that right? 125 kilograms per cubic meter. That sounds a bit too high to me.
I have no frame of reference for what that means.
Well, it's 1.3 on Earth. 1.3 kilograms of atmosphere per cubic meter at surface pressure. So from roughly reading this graph of Jupiter's temperature and pressure, you'd expect that's about 10 times thicker than the atmosphere on the surface of Earth at the point in Jupiter's atmosphere where the pressure is equal to our atmosphere. Which actually, when you think about it, makes sense. Because you've got a gas that is way less dense per kilogram. So you'd need many more of those kilograms per cubic meter in order to get the same density. So, yes, it would feel soupy.
Yeah. But we're also assuming that light travels the same through this hydrogen gas as it does through oxygen, which
I don't know what hydrogen's absorption spectrum is off the top of my head. So that's basically what wavelengths it absorbs.
In a gas, can a gas be dense enough to block out light while still being a gas?
Yeah, because it's not necessarily the density. Well, no, I suppose it is correlated with the density, but it's what wavelengths of light that gas absorbs at. So if you found a gas that absorbed somehow all visible, wavelengths.
True, but I'm just thinking that gas is like mostly empty space, and atoms are mostly empty space. So in order for something to block out light, it would have to be like really super dense. And at that point, isn't it like?
Yes, but it's all relative because, if you were to purely use like a certain band of infrared wavelengths to look through the Earth's atmosphere, at the surface it would be completely opaque because there's so much CO2 in the atmosphere. Even though it's a very small part of the atmosphere by composition, It's actually
it does the good absorbing.
Yeah, which is why you have to get quite high up in the atmosphere in order to be able to see out, which is the point at which radiation can leave.
So when you think about life on these kind of planets, what you're actually getting is selection for specific wavelengths, like
in the deep sea, right?
Yes, yeah, because what is it?
Photosynthetic.
Is it red wavelengths get through water more easily?
Red either does or doesn't. Oh no, damn it.
As you get lower, stuff gets redder. So there's red stuff at the bottom.
There's
so
red stuff at the bottom
doesn't get
because
through.
red doesn't get through the deep layers, and therefore they're all camouflaged in the dark. And then you shine a light on them, they're actually like red, and it's like, why are you red? It's like, oh, there is no red here. Red doesn't exist.
I was just looking at the hydrogen absorption spectrum. There are basically pretty healthy absorption lines in kind of turquoise, like bluey green, and in quite far red. So you'd have those colors removed from white. So if you remove some green and you remove some red, that basically leaves blue, right? Think about color. If you think about Photoshop, if you're dragging down your R and your G,
you've got blues and violets and maybe a little cheeky bit of yellow in there.
So looking up, I assume
not that.
I assume that would mean it would look blue.
No, because blue reflects, right? So it would look everything but blue. Because basically, if blue is getting through, you want to absorb the blue to generate to build whatever molecules you're building. So you living things are going to absorb anything blue. So you are going to be the opposite color.
Oh yeah. Because I know the rocket fuel is quite blue, and that's primarily. I don't know.
Rocket fuel is blue. What is rocket fuel?
Just spilling it all over themselves.
It's oh god, what is rocket? Chat, you're gonna have to help me out here. I read a book on this once.
What's rocket fuel?
Dear God, chat, where were you when we needed you?
What's rocket fuel? What's rocket fuel?
What is and what color is rocket fuel? Isn't it nitro?
It's hydrogen. Well, actually, yeah, because it's hydrogen and oxygen that you mix together, right? That's like what liquid rocket fuel is. It's liquid hydrogen and liquid oxygen. So yeah, it being blue would make sense then. I reckon hydrogen's blue.
And I reckon I trust you.
I
trust you, Simon.
Everything we said here, absolute scientific fact, especially the bits prefaced by I reckon.
So in conclusion, I think Fogtown would be a very soupy atmosphere. If you're going to recreate the part of the atmosphere of these gas giants.
What do you mean by soupy? Visually soupy or?
It would feel soupy.
Good.
Okay.
And it could potentially be a little bit cloudy. Like that's artistic license, however much cloud there is, because you could have a little bit of ammonia as a treat. But it would be blue, and it would be very cold, like really cold.
Taliana would like
That's really interesting to think about.
Megan's saying in chat, it's like walking through like a deep frozen liquid Smurf.
No. What did you do to the Smurf?
Why are we here now?
So that's where we went for a drink. We thought we found a really cool place to go and have a drink.
Oh dear. The science of us having a drink / a lot of atmospheric physics.
It's so interesting to think of this because it does feel suddenly very oceanic when you describe it like that. Very cold, like soupy, light, kind of like diffracting off stuff and like sort of just sort of hazy and stuff like shadows coming out of the mist and
here we go. Yeah, liquid hydrogen. I can't stream this very easily. I'll pop it in our group chat so you can see. But there's someone pouring liquid hydrogen, and you can see that it's transparent, but it is tinged blue in a way that water isn't.
Wait,
I do not see that. I just see liquid. Wait, I'm going to zoom in.
Put it on the Discord.
Oh yeah, put it on the Discord. It's only slightly. Like this is a very small effect. But
I want to cut to break, but like Hogan has put a really good question.
Oh, go on.
In chat, which is if you flap your arms super hard, could you fly? The atmosphere's more dense.
I know that you can. I definitely know that someone worked it out, and you could do it on Titan. Like you could fly on the surface of Titan if you gave
Titan
yourself.
Like?
It's methane. It's a similarly dense atmosphere.
Oh, okay, super dense.
I don't know off the top of my head.
Methane and Jupiter hydrogen. Is it because all the methane's near the center?
Oh, that's another good point actually. Which is the thing that matters there is the gravity. So Jupiter obviously has a very strong gravitational whereas Titan has a thick enough atmosphere, but it's also
small,
very small. Yeah. So yeah, there's an XKCD where it's like, what would it take for you to fly on each one of these planets, and Titan is like
cool.
Leonardo da Vinci style wings that you basically strap to yourself.
That's very cool. Okay, I think we should have a break there. These are going to be slightly shorter streams than usual. So yeah, we'll have a little break. We'll come back in maybe 5-10 minutes, shall we say?
Mm-hmm. We can do 5, unless anybody. I've roped us in now. No, we can't do 5. We can only do 15.
We'll do 5 apparently.
Okay.
I said 10. I thought 10 was nice. 7.5 minutes. Chaotic's gonna be like, where are you? You said this time. Germans.
Chaotic would be right to do that. Timer begins.
An unspecified amount of time. Have a nice break, everyone, and we'll see you back here for more science. In a number of minutes.
In a number of minutes.
I want to be clear. There's no choice about that. Like, I know sometimes we say or don't. There is that option doesn't exist here. We will see you back.
Shall I roll a dice and we'll see how many minutes it is?
Oh no! That's gonna be bad for us.
What D will it be? What D?
Can you at least
what D shall I use?
So we want a range of somewhere between like 5 and 15, right?
D12.
D12,
surely.
No, but I want to reverse.
Fuck. What if it's 1?
Then we have a 1 minute break.
I think it should be D6 plus 5.
Oh, someone's playing the new edition of Warhammer.
Right?
Okay.
Because then it can be from between 1 and 11.
We're gonna have a las cannon of a break, everyone.
Or D8 plus 1 plus 5.
Is a las cannon D6 plus 5? That seems.
No, so I think the Godhammer las cannon's a D6 plus 3 now. We can do. Oh, the new edition looks so good. The new Death Leaper is so. We can talk about this.
Do you think we should?
Right, D6 plus 5 minutes, everyone.
Okay. Oh shit. Okay. Right.
7-minute break. I like this as a mechanism. Right, we'll see you in 7. Hi, everyone.
That
was 7 minutes. Oh, look at that. The timing. She's back in the room. Oh, no, it's all good. You knew how long we had. Also, by the way, happy birthday, Sam Size. In chat, it's their birthday today. .2 seconds too late. Catastrophe, says Chaotic Brain Person.
Sam Size.
Happy birthday.
Sam Size. Happy birthday.
My degree certificate keeps going down, doesn't it?
You made it.
I'm fine. It's fine.
Emily Bates has weighed in on the private chat to
investigate
us. Yeah.
What? Wait, what happened?
No one say anything. No one say anything.
Oh God.
I love that.
Because you were messaging me saying we have to go live now. Bates is like, how have you not gone live yet? We went live, Bates. We're fine. We're professionals. Everything's fine.
No one reply. I want this to be the new version of the chat that Ali created with the rest of us. And I was like, Shamini, don't say anything.
Oh, no.
See how many messages he sends in a row.
Fuck you so much. That was so cutting.
You were like, hello? Is this thing on? Can you guys read these messages?
I didn't know what was happening.
It was so funny. And then Shamini ruined it. She was like, I had to go and talk to him.
Poor Ali.
Hi, Cap. Emily's been replaced with a dice because she is working on Springwatch. She has a real job, and we are here to pick up the pieces. But don't fear, the regular episodes are still coming out. Next week's episode is a pre-record that's already in the can. Hopefully you won't really notice anything is awry. Emily is a very successful video person.
Emily is very successful.
I'm not a bully.
Thank you, Cass. I didn't know what was happening. My normal safe foundation. What are you doing? Are you smoking a gas? What's that?
It's a freeze pop. It's like a Mr. Freeze.
Simon's eating a freeze pop.
It's ideal for these conditions.
Because
I have a real kind of. I was really worried actually because I realized, we smoke a hookah in the gas giant as a way of having a drink, but really that's just eating the still living flesh of another creature, isn't it?
Isn't what?
What? If it's a gaseous life form, it's like what? Instead of hookah, it's
everybody there just screaming noiselessly as they're watching us. I
have no mouth and yet I must scream. I have no cell membrane and yet I must scream.
That was the point. I felt myself rack up for a segue. I inhaled. It was and that brings me onto it. And then I realized there was no way I could segue between that and what I have to talk about.
Make it work, Ali. Come on, you're a professional.
Thank you.
Let me another loop.
I'm gonna re-intro. Thank you to anyone who is joining us live.
I've got it.
We are here with Science of Starfinder. And we have heard all about gas giants. And now Ali is here to segue.
But did we, Shamini? Did we hear all about gas giants? I know we remember hearing about them.
Oh! Yeah.
So good.
Very nice.
Professional streamer, everyone.
Yeah. I enjoyed that.
Take that, Matthew Mercer.
Gives nothing away. Oh, God. Yeah, so
do you want to recap what happened in the story, or shall I?
You recap. You do it so well.
Oh, I don't only have my notes in front of me. Right, so I'm going to enjoy this recap because this was me trying
Speaking of notes, can I do a sneaky plug? Is now a good time for that?
Sneaky, yeah, do a sneaky plug.
Can I do a sneaky plug? Everybody, sneaky plug! So sneaky plug, if you are as interested in Shamini's notes as this plug's going badly. You can see Shamini's notes. Shamini makes the most amazing epic notes. They're full of drawings and it's literally, word wall to wall. The margin on a piece of paper completely ignored, right? It is. There is no space for anything but words and tiny drawings, and you can see all of those notes if you come and join us on Patreon, where you'll also find me as soon as you enter. I'm Heimdall, Simon. Don't look at that. You just looked at me oh no.
For anyone who wasn't here earlier, there's a whole thing. It's fine.
I signed up to be on a public project with this guy.
That was the expression that came across your face. Like you couldn't help it. Anyway, but yeah, so you can see them, and they're well worth seeing. Come join us on Patreon. Okay. Anyway, they are good. So, Shams, recap.
Right. So, I enjoyed this because there was involving my character stuff that I had discussed with Emily Bates, but had to sort of portray. And what we had discussed is that my character has a sort of gap in her memory, and she remembers getting off a space station in Absalom. Wow, it's so amazing here. And then she remembers arriving at the Eyes Wide Detective Agency. And when I described, and then she went somewhere else. And when I described this, actually, like as I said at the time, like I think it was too subtle. But what I said was like, oh, I described like getting off the ship in detail, and then I just sort of jumped to being at the detective agency, and then I like described the rest of it in detail, and then I got a taxi, and it was this much money, because she doesn't actually remember getting from the getting off the space station bit to the arriving at Eyes Wide bit. But what we figured was you wouldn't experience that as a sort of, as a blackout or a blank spot in your memory. You'd just be like, trying to remember and being like, yeah, and then I went to Eyes Wide. And you're like, yeah, that must have happened. So yeah, I vaguely remember doing that because I must have done. Is that...
I'm gonna jump in there.
Is this how brains work?
I'm just gonna jump in there for a second.
You should.
I
think so. Oh yeah. Hi, hello everybody. I think what you're talking about there is two different things, right? So one of them is false memory, where you remember something that just did not happen. But the other one is confabulation, where somebody asks you something about which you think you should know the answer. Or you are challenged about something, or you yourself think you should know something, but you don't know it. So your brain just makes up a story, and then you just believe that story. And people confabulate about all sorts of stuff.
I did it for a whole degree.
But they don't realize it's untrue, whereas you, Simon, knew you were lying, and you did it anyway.
Pretty sure I should know about this.
Yeah, so it's called Dr. Simon Clark thing. You're gonna have to
just gonna integrate the Force. Yep, that seems about right.
Just do one of those little loopy S's.
Yep.
Dr. Simon Clark. You heard it here first.
But
if you're confabulating and you make up the story and you believe the story, it's not the same as like, and I remember it happening, so it's a false memory. Like, yeah, I must have got the taxi right, and yeah, I think I remember that. Yeah, I remember getting in the taxi, and then you have this false memory of what your story was.
I don't know is the answer. Basically, I did look up confabulation during my research because I was like, this is the obvious place where this goes. But there's actually not a huge amount of research that I could find on it. It is difficult to...
Researchers, when they were asked about it, just made something up.
They could have. Though, like, it's difficult to kind of pin down the neurological roots of it. Like, it does happen in certain cases. Lots of people, sometimes it's brain damage that does it. So there's definitely something in the brain. So there should be more on it. I don't know why I didn't find it, because I did look for it, but I didn't find it. But if anybody else can find it, I'd be really interested to know, and it would definitely feed into the stuff that I did find, which is a bit more kind of classic. Like, there's lots of work on false memory.
Is there lots of work on false memory because it's super relevant to like court cases where you're asking people for evidence, and therefore everyone's like, we should probably find out about this.
Yeah. So absolutely 100%. It's yes. Simon?
Brief aside, because I was really curious about where the word confabulation came from. Because that's a great word. That's a delicious word.
Very good word.
It's a lovely word.
It's from the late Latin confabulationem, which is basically a past participle of the verb to converse together. So I guess it's referring to the fact that you are creating an idea through conversing with someone else. Like, it's a memory that you create through conversation with someone.
That makes sense.
Which that's such a cool word. Great word that needs to... That's a Scrabble right there.
Etymology corner.
I always imagine it a bit like a sort of like a Punch and Judy set that opens up, the curtains open up, and then we get the etymology, and then they close, and we sort of the camera pulls back. But
one day we'll have the budget to do that.
Yeah, one day we'll have to set it. Yeah, really,
yeah.
And with the puppets and everything. So,
Puppet Simon. Etymology.
So here's something that should give you pause for thought, right? So, all right. So, okay. First of all, it's not just like someone you get put in the witness box and someone just grills you over and over and over again. Like I could potentially instill a false memory in you by gaslighting you, right? Being like, don't you remember going to get the food on Wednesday and you didn't get the yogurt, which I specifically asked you to get? And then you could be like, I don't remember going to get the food on, and you'd be like, yeah, don't you remember you went in the car because I couldn't go in the car? And then you're like, and suddenly you start to, so these that's a real sort of, it's pretty, and it's super, super interesting because it sort of gets to the heart of what memory is and how it functions. And I think so in the 60s.
I mean, that is a lot of like my conversations I have with people are like that, but I don't think it's because they're gaslighting me. I think it's because I have a very poor memory. But when they say like, don't you remember? I don't know whether I really do or whether I'm just like, oh yeah, like, I don't know whether I'm making my own false memories just because I know that they're probably right.
So there's lots of stuff you can do to sort of trigger false memorization in people, and that feeds into that. Anyway, and if you do a meta-analysis on the literature, which has been around for a while, right? So, but it's not huge, but since the kind of 50s and 60s, people knew about this stuff. If you do a meta-analysis on the literature, you find that about 30% of everyone who they tested to see if they could get false memories got them. So that's one of us, pretty much.
Wow,
would be
less
like,
than I thought. Actually, I think it might be me.
But remember, this is in a scientific setting, so in an experimental setting, you can induce.
But they wouldn't know what the experiment was, would they? Yeah.
No, they wouldn't. But if you'd be like, right, I'm going to give you a false memory right now.
Yeah.
Let's do it.
Do you know what kind of things it was? Was it one of those ones where it's like, do you remember when you came in and there was the biscuits on the left? And it's one of those ones where you think the experiment starts when you were actually it already started when you.
No, and I think normally what they do is they flip it so that they say, or at least the one that I read most about, they flip it so they say, this is an experiment about memory. We're just checking to see how good at remembering stuff you are. Do you remember this thing which you did? And then it never happened. And they're like, I definitely want to remember that thing because my memory's great.
Oh man.
This is like it's the episode of Rick and Morty, I've just realised. When they have all the Mr. Belvedere and all these characters that start appearing, and it's like they're all aliens that give the impression of memories.
It's a parasite, isn't it? That,
like it feeds off their memory, which again I think I mentioned this last time. It was like it's a very Star Trek idea.
I got 11 minutes into that episode, and then my wife came home.
And you were like, I'm watching nothing. I was watching pornography.
It's
easy to explain.
You were watching, this is your pornography? Cerebral. Yeah. So 30% of people, which is pretty impressive. And these, what's also kind of cool, I say cool, it's kind of funny in a way, is that obviously these false memories, right? As soon as people remember them as being real, then they transmit them, like socially to other people, and they tell people these things happen. And there's this really famous,
as in they transmit this to other people, as in like they'll tell like.
Oh no, they tell them with their words.
Bob on the call, like, oh, I did this thing, or do you mean like, hey, don't you remember when we did this thing? Do you mean they transmit them like?
Oh, hey, that's a great question.
Was that person involved in the thing? Or is it
That's
a false memory for them too? Are they just... Yeah, you know what I mean.
I don't know. That's a really good question.
Cool. That's
but that would be
that would like memory virus. So that's also a very Star Trek idea.
Yeah.
But that would essentially be like that would be like giving someone else a false memory through the techniques which the person first gave you one. So I guess
but unconsciously, because you don't know it's false. Right? Memory virus. Let's do it. I'm gonna make a one shot.
Let's do it.
It's gonna be a really hard one shot. Can you make a one shot for us that's all like memory thing?
All about false memory.
Really cool. Yeah.
Oh god, I can't
feel like you
begin to imagine how hard that would be to write.
Yeah, that's why I gave up on writing it and I'm asking Ali to do it for me, because I think you could do some cool mechanics with like, you remember this, but like you never know whether your memories are real or not because the DM.
That's how you basically you wake up and you know that something is a lie.
Oh no, you don't know what?
And everybody has a different recollection. But this is kind of standard. Everybody's got a slightly different recollection of what's happened. But some of the things overlap and you just don't know. And you have to discover what's not real before you die.
Or what if you as like DM, you ask the player, like, where did you get that item? Or whatever it is. Or, what were you doing last night? And then behind a screen you flip a coin. And if it's like heads, that's what happened. And if it was tails, it was a false memory. And then you construct all the things that really happened, and then you use that to drive the story on.
It's going to be very confusing.
I mean, mind-melting game to play.
Yeah. My brain is melting already. Do it, Ali. Do it.
Yeah, okay. Wreck us, Daddy Ali.
Yeah. Oh, it's a nice experimental one shot, isn't it? That will end just in just the stream just cuts out halfway through someone's sentence.
Yeah.
Yeah, that's it. Anyway, but there's a really famous account of a particular false memory that was transmitted, like massively transmitted. Okay.
And it started with, Moses, where did you get those 2 tablets with all those commandments written on it? Someone gave them to me.
No, religion is completely reasonable. So, when Nelson Mandela died in 2013, everybody knows this story. There was a group of people who were convinced that he'd actually died in the 80s in prison. And they formed, and so many people had this same memory that they formed a community, an online community of people around this.
And when you say so many people had the same memory, did they have it, or did someone else tell them they had it, and then they were like, "Oh yes, I do have it"?
I do not know.
That would work.
I don't know whether they whether they were whether it was appearing de novo.
How many people independently had the thought, or how many people heard someone else say, "I remember this. This already happened," and then like looked back and thought like, "Oh yeah, I know, I do remember it happening," but like they wouldn't have thought of it otherwise.
But it could be something, it could be a lot more sort of like fragmented. Like someone could remember that they died in the 80s, someone remember in prison, and then they'd meet and he'd be like, yeah, I guess it must have been in prison. And suddenly, you've got kind of a new one being formed. Anyway, so false memory, it can happen, which made me think, basically I was thinking, okay, false memories, yes, all very interesting. But what's most interesting about them, I think, well, to me anyway, was the kind of light that they shed on actual memory. Because if you go back to the studies, false memories and real memories are indistinguishable by the people who have them.
Shit. Okay, by experience, are they indistinguishable if you put them in a scanner? That's the kind of thing you
don't think that's been done, but we can look. Or it might have been done, and they are indistinguishable.
So your question there is, you put them in an MRI scanner, does a different part of their brain fire if they're recalling a memory they think is real but is false versus an actual memory?
Yeah. So I have not seen any literature which tests that, although it must have been tested because it's a very obvious experiment to do.
We've got to get funding.
I don't know.
I think we've got to get funding and we've got to do this.
The instant that could be our camera, couldn't it, of the experiment? Just someone doing an MRI, trying to remember some stuff.
If you're in chat, you get to be a co-author. All right, patrons go higher up.
Like there's mad physics papers that's got 1 million co-authors.
Yeah, yes. I think the record's the one that was the discovery of the Higgs boson, the confirmation of the Higgs boson, because 2 of the authors on it were dead. Like there were something like 2,000 authors, and I think 2 of them had passed away between like the start of the experiment and them submitting
2,000.
Something like that. I'll look up the number.
That's pretty good. So, right. I just thought I'd do a very quick recap on how memory works, like the common or garden standard memory.
Yeah, I found it, by the way, just very quickly to avoid derailing a beautiful explanation. The team that discovered the Higgs boson had 5,154 authors.
Whoa.
The paper is 33 pages long, 24 of which is the list of authors and their institutions.
Oh, no! That's awesome.
Oh, and hang on. What was it? Had the paper that announced the Atlas team. So this, I think, was the overall Higgs boson. Yeah, the more precise estimate of the Higgs boson. The initial estimate had 2,932 authors, of whom 21 were deceased.
Oh, no.
That's nearly 1% of all the authors on a paper is dead, which doesn't sound like a lot. But that's still 21 dead authors.
21 people. Yeah.
I'm pretty sure I was dead inside when I submitted my paper, but counts.
Ouch. Anyway, right. Sorry. How does memory work?
So, you've got 3 stages: encoding, storage, and retrieval. And for encoding, basically you're taking sensory input, modulated by whatever's already happening in your brain, right? So that means like whether your mood, or whether you're particularly goal target focused on something which is happening, and whether that's relevant to the memory that you're kind of encoding at the time. And I don't know who out there's brain nerds, my brain peeps. I just love the way the brain's put together. It's put together in a really funky way. It's got loads of crazy bits, and I'm into it, right? I'm down with it. And one of the
where my brain peeps at.
Where my brain peeps at? Can I hear it in the chat?
That's one to put on a t-shirt.
Where my brain peeps at.
And it's like a brain that's made out of circuitry or something, and then where my brain peeps at. Ali Jennings 2023 underneath.
And then no one replies.
Yeah.
And then what? And then an empty chat box next to it.
Yeah. And 2 ticks for scene.
Yeah.
2 ticks, the Ali Jennings story.
2 blue ticks. That's what it would be, wouldn't it?
Some people in chat like the brains. You're all right.
Okay, all right.
It's all zombies. A lot of you.
But that's fine. It's fine.
So, right.
Too hard.
If you think about, just think for a second. So, like a huge part of your brain is devoted towards sensory input. Like masses of it is devoted towards vision, because that's fairly complicated. And then a good chunk's auditory, and then you've got a lot, which is somatosensory, which is your skins. And then you've got a kind of a funny sort of rump bit, which is your olfactory, which has got a bit of kind of strange, like piriform cortex, I think it is. Anyway, and it's also got like an olfactory bulb and some other shit. And then you've got the taste, which I think is olfactory as well. And then you've got the 6th sense, which is proprioception.
Okay.
New proprioception, which is all the internal movements of your. It's
knowing
like
where your hands are at all times.
This is what also we were talking about in the show the other day, about like how your stomach flips if you're in zero gravity or going over a hill, because you feel your organs moving.
Should have found that out. That would have been a good one.
We were wondering about that.
Yeah. Anyway, so all that stuff is coming in, and it basically the information always flows both ways, right? So it flows even back down into your spine, probably not back to your actual like sensory neurons in your skin or wherever, but information is flowing from the kind of the higher processing parts of the brain back towards the sensory processing parts. But in general, information increases in complexity and in abstraction the further towards the prefrontal cortex you go, which is the forehead bit, which isn't linked to any particular sensory input. It's linked to all of them, and it also gets lots of inputs from everywhere else, like about sort of mood and decision making and all that kind of shit. Anyway, the prefrontal cortex, along with direct inputs from the different sensory cortices, sends its information to the hippocampus, which you might have heard of. My brain peeps.
Yep.
Come on.
Horse University.
They've heard of it.
I've been talking about this for 3 years on stream.
Horse brain, yes.
Horse brain.
Yeah.
Horse brain. I've got donkey brains.
I sometimes think about it. I mention this, I would say 2 or 3 times every stream.
Yeah, it checks out.
Where my hippocampus peeps at. Silence.
Yeah,
there are no hippocampus
always
peeps.
2 ticks, the Ali Jennings story.
Look, chaotic brain person loves your brains.
We also, Ali, I don't know if you read this in chat, but we had a chaotic brain person looked up an MRI study on false memories.
Yeah.
And there was a difference.
Parahippocampal gyrus.
In the parahippocampal gyrus, is that in the hippocampus or is it just parahippocampal?
It's parahippocampal. It's not. It's so the hippocampus isn't cortex. It's. I'm glad you asked me this, Simon. The parahippocampal. Basically, your brain. The wavy bits on your brain, like the way where it looks like a walnut instead of smooth.
Yeah.
It's crinkly.
I like those bits.
Yeah, that's
bits.
gyri and sulci. Those are called. So the gyri are the bits at the top of the peaks, and the sulci are the valleys.
Oh.
So the parahippocampal gyrus is just the wavy bit that goes out next to the hippocampus.
Cool. Very cool.
That's how we do. That's very interesting that chaotic brain person you would find that, because a parahippocampal gyrus is next to the hippocampus, and it will be part of the routing. So basically, information gets routed through those areas, like the parahippocampal gyrus and the entorhinal cortex, which is the one which is next after the parahippocampal gyrus, to the hippocampus. And the hippocampus basically is a very specific piece of circuitry. So it's built in a way that the rest of your the neocortex, which are the crinkly bits, aren't built. The neocortex, which are the crinkly bits, have a very specific structure, which is quite it leaves room for lots of connections and lots of sort of processing, but it doesn't do like one thing really, really well. It's very malleable and changeable.
I feel like I've really you've told me a lot about brain anatomy, and I've really lost the sort of core point of what I actually need to know. It doesn't matter. All this. Like,
it's irrelevant now.
What was?
No false memories. Only hippos.
Do I need to?
Only hippos in the
brain
chat.
anatomy do I actually need to know for this?
Yeah. Okay. Well, all you need to know is that the hippocampus basically binds all your sensory information together, and then shoots it back out into your cortex for storage. So the hippocampus does encoding, and then storage is where all those, where all that joined up information is sent out to be stored, and it's stored in things called engrams.
Memory engrams.
I thought they were. Yeah. I thought they were just on Star Trek. I was thought they pronounced engrams, but that might just be the
Americans.
They
can't talk properly.
Get off my engram, you pervert.
Because that Star Trek episode, the virus is a memory engram that jumps from person to person.
I just thought they were a sci-fi thing. How on earth, in real life, do you define an engram?
Oh, I'm so glad you asked me. A memory engram is a collection of neurons connected in a specific way.
Okay.
Right. It's like a circuit that's formed biologically.
A little network. Yeah. A little bundle. Okay. Are those neurons only part of one engram, or?
Well, no. So they can individual neurons can be part of multiple engrams.
And then you just draw a circle and be like, this one is this engram, and then you draw another circle.
So you can. The parts of the circuit can be parts of different engrams, and you can activate those engrams experimentally and trigger a memory if you do it with lasers, and only lasers.
And how specific a memory is it? When you say an engram is kind of like a memory, like, are we talking about like what an apple looks like, or are we talking about that time you ate your apple at your grandma's house? And
you're talking about declarative versus episodic memory. So declarative memory is facts about the world. Episodic memory is facts about your own life, which you did.
And which type is it? Both?
I don't know. Oh. That's a really good question. I think it's both. But essentially, the one thing it's not is procedural memory, which is movement. But that's not answering your question. So I don't know.
Okay, so there are little memories stored in the little engram networks.
Yes,
which have all this input for different sensory things. Your mood affects it as well. Like if you're really angry when you learn it, that will influence.
Do you know why that is? I love this shit, and we never get to talk about it.
Is it because of the brain anatomy you were talking about earlier?
It's not. Although we should talk about that more.
Oh no.
No,
why? Why is an angry memory different from a happy memory?
If you're a brain peep, which you all are, and I know it,
we are now.
Then you basically you would say that mood is a function of the different chemical makeup of your brain at any given point.
Sure. Okay. That's a mood.
And those chemicals interact with synapses, which are the joining points between neurons, in different ways. So your engrams are built by strengthening the synapses, which are the connection points between a group of neurons. And so by activating one, you activate all of them because they're all strongly connected by synapses. And depending on what mood you're in, changes the chemicals that change how those synaptic connections are formed.
And presumably, the more frequently the connections are made, the stronger that memory becomes.
The more frequency, the frequency? No, so they're made once, but the more frequently that they are used, as in that the more frequently you use that synapse to reactivate the memory, the more they are strengthened, yes.
Yeah.
Are you saying that mood is like brain chemistry, is like a soup of molecules that are outside the cells, the synapse being obviously the gap between the cells?
That is what I'm saying.
Inside. That's so. Wow. So you've got all these electric signals going down these cells, which are neurons, and like most of our brain function is all these electric signals, and then you have overall this liquid that could contain different.
So if you were a gaseous life form, that wasn't self-contained. You'd float through the atmosphere and be like, the mood in here is off. Like literally, the vibes in this part of the planet are not good. I am straight up not having a good time.
That guy's I kind of like that guy, whoever that guy was. Like, I need more people like that who just come into a space and are like, you know what, the vibes in here not great, not having a great time, sorry about it guys, I'm out.
Yeah.
And then just drifts off.
We can all
respect to you, my friend.
Yeah, we can all learn from this.
Yeah, we all need to be. Yeah, well, so it's not like a soup, right? Which is homogeneous. It's more like spatters of different kind of pockets of chemicals here and there, and yeah. Anyway, but what's interesting about that is it's not just so that there are chemicals, so endogenous chemicals your brain produces naturally, which set your mood and change depending on the situation you find yourself in. But also you can bang a load of drugs, right, of various kinds, and change the internal chemistry of your brain, right? That's basically how drugs function. And that's why lots of drugs have like profound effects on mood, because they just and they change the concentration of chemicals in this surrounding your neurons.
So why is it I can't have grapefruit juice on like antidepressants? Is that because it introduces a chemical that fucks with the pathways?
Well, I'm just going to completely guess, and I don't feel great about this because I don't want to.
This is not medical advice.
This is 100% not medical advice, and I don't know the answer, so I'm going to put a guess out there. And if anybody wants to check if it's in any way correct, that'd be great. My guess would be that let's go for it. That there's something in grapefruit juice which fucks with the breakdown of the chemicals, because essentially, if you're dosing at a particular strength, right, and at a particular frequency, if you change the breakdown of the molecule in your system, that's going to change the actual dose within your system. So that's probably more likely rather than it having an actual effect.
So it could be that you're inhibiting the breakdown, and then suddenly you've actually have a larger dose that's built up, and it's like a dam bursts, and suddenly you have a larger dose being applied over a shorter period of time.
Yeah, you would inhibit the breakdown and thus increase the concentration, the active concentration. And so you would
because grapefruit juice is one of the ones that you really commonly hear as like a side effect of.
That's really so just from a very brief
it's
Google,
just a suggestion though. We don't know if that's
really
true.
Close, I think. So
to the answer.
The FDA website is the top result, and it says that grapefruit juice can block the action of this enzyme that breaks down the drugs. So
Brain boys, let's go! Brain boys, let's go!
Let's go! Is this happening? Am I doing it right?
We've had two actual bits of science. I did a calculation live, and Ali just was like, yeah, it's probably this brain chemistry thing. It's probably a bit like this. Dead on.
It's in your guts, though. It's not in your brain. It's in your guts.
Yeah, but I did that.
Chemistry is important too.
No, but I don't want to justify myself. I'm just gonna live. I'm gonna walk away. Everyone. Anyway. By
the way, Shamini, are you drinking like a corner shop Ribena or something? It's like you're drinking a Ribena out of a brown bag.
For those of you who cannot see this, it's my water bottle wrapped in a piece of brownish cloth tied with leather cord, and it's because I went LARPing and I needed in character way to drink, so this is my disguised water bottle. It is sadly just water, however.
How was LARPing?
I don't want to talk about it.
Oh, okay.
I had a time.
I think if the four of us went LARPing, we would fucking kill it. Like if we all went to the same, because I've been invited to Empire LARP near, like it's Southwest, I think it's not too far. From me.
That sounds deeply not good.
But like, I know a lot of people that do it, and they have a whale of a time.
I mean, they sure did. But
I'm not sure it's my thing, but it's one of these things I wouldn't like be averse to trying once, because like you gotta try.
Why not? You gotta try it.
Turn up, RP as bards the entire time. Don't elaborate. Leave. Like like we could have such a fun weekend.
I'm gonna come as a paladin, full plate mail, shield, whatever the LARP is.
Yeah. Hail, citizen! on a spaceship, like it's Warhammer.
That's dope. Oh fuck.
Actually, Warhammer LARPing sounds awful. Like Warhammer 40,000 LARPing is the last thing I want to do.
Sorry. I just read something from my notes. Simon, remember you were saying that when you play, if you reactivate a memory engram, you strengthen the synapses because you're. So actually, they think sleep is very important for memory storage because you get these things called sleep spindles in the hippocampus, which are very, very, very condensed bursts of activity. And when you look at them and you look at the cells which are bursting at that time, what you see is that they're playing in reverse, I think, the position of the rat this is in space over a period of time that happened when they were awake. So they're mentally replaying what they did during the day, but they're doing it. The cells are bursting at very high frequency to basically lock in those connections to solidify the memory.
Right. Okay.
Did that make sense what I just said?
I think so, yeah. It's almost like you're mentally retracing your steps, and then it's like, that's the pathway. Cool, we know what this pathway is. We did it once, we're going to do it backwards. That's it.
And you go.
And I suppose this is also why spaced repetition is a revision technique that works really well. Like, you do the same thing the following day, the following week, the following month, and it's going through the same process.
So it's interesting. So it's because the environment that you're in and the mood that you're in affects how you remember and how you could recall as well. So actually, there's a good experiment they did on students, obviously, where basically they took a cohort of students and asked them to remember something, and took another cohort of students and got them hammered on booze, and then sat them both sets down and said, "Oh, can you sober?" and asked them to remember the thing. And the people who remembered it, who were asked to remember while they were sober, remembered it. And the people who were asked to remember it while they were drunk could not remember. Then they got both sets of students drunk and asked them to remember it again, and the ones who remembered it sober couldn't remember drunk, and the ones who remembered it drunk could remember drunk. So it's less that the booze gets rid of your memory, it just means that you are very situational about how you can recall things, i.e. you can only recall stuff when drunk.
There is a really fun idea for a story, or like a one shot there, where like you do something incredible, like you do an experiment, for example, that changes the world of science, but you're hammered at the time, but you can't remember how you did it until you got appropriately hammered, and then you have to try and write it up, or something like that. Like, I think there's a thread there for a one shot.
Is there? So
science.
But that was a thing, wasn't it? Anyway, so back to false memory, right? Because this has all been a long preamble. And it has. So let me just read my notes.
I kind of forgotten at this point that we hadn't actually got to false memories.
Oh yeah,
yet.
I thought we had.
Or
yeah,
have
we
we?
learned
No.
so much, and I'm like, no, we haven't. What about the false memories?
Shit-faced science.
Yes.
It's like Drunk Kitchen, but drunk science. I like that.
Yeah, pretty good.
So, okay, right. So this is the take home. If you are looking to instill a false memory in someone, so let's think back, Saliana. If any of that isn't real, here's what they would have had to do to instill that false memory in you. So the script that the experimenters use to kind of give you this false memory is, first you provide them with incontrovertible false evidence of this memory. So they'd be like, when they were interviewing,
they've got to believe you first, right? They've got to actually believe you.
you have to say from a position of authority, like this is what happened, right? So that's the first thing. So like in the experiment, they were like, I asked the person, oh, do you remember doing this thing? The person's like, no. And they're like, oh, that's interesting, because in the questionnaire that your parents filled out, they distinctly describe you doing that when you were, 12. You sure you don't remember that? Then social pressure, which is like it's like the special source of all psychology experiments. If you give social pressure, you can make people do pretty much anything. So then they say things like, most people are able to retrieve lost memories if they try hard enough. It's just like, that's so nasty. Like, imagine, most people can do this.
This is Ali's supervillain origin story. We're studying neuroscience. Now he's gotten all the ways to.
But at no point in Thali's story has someone said to us, well, as far as we know, no one said to Thali, like, oh, you remember the past year? Like, we did this and we went to the park and we...
You should try it. Maybe it'll work.
Yeah, maybe.
We went to the park. We had a great time. Oh, that's nice.
Whereas as it is, you have a memory gap, basically.
Yeah.
But you've got a memory gap.
I filled in the memory gap with, like, we didn't really get into it, but like, I think it's quite plausible that if someone said, well, how did you get to Eyes Wide? That, I could think, well, I must have got a taxi, right? Yeah, I think I got a taxi, and maybe it's not the same as when someone else implants it in you.
Well, I think that's confabulation.
Yeah.
But in a way, you could expect the confabulation is running on the same system. It's just it's you that's providing the input.
Yeah, you're convincing yourself and being like, was the taxi blue? Yeah. Probably.
What if
that other taxi later was blue? So yep, I remember. I've got a vision of it now.
What if Thali spent an entire year stage 3 drunk, and in order to access the memories, we have to reach stage 3 drunk?
I never got to stage 3.
If we had, we might find out what's. I think as a science experiment, our characters need to all get stage 3 drunk.
Yeah.
I was trying.
yeah, you were. In the name of science, you were trying to find out what would happen.
But anyway, there's all sorts of other kind of like things that they do, like you build a rapport with the participants. You use pauses, lots of pauses, to allow the participant to be like to respond and build up their own memory. And then further, this is a direct quote from the paper. Further, when participants reported that they could not recall the false memory, the interviewer seemed disappointed but sympathetic, while saying the scripted line, "That's okay. Many people can't recall certain events at first because they haven't thought about them for such a long time." And then they scribble a note on their clipboard. That's in the instructions.
Interesting.
Oh, interesting.
Do you think it says like write for 3 seconds? Like, it specifies how long it is. Because
so tightly controlled.
I do remember when I was in therapy, my therapist, I said something, and I can't remember what it was. I genuinely can't remember what it was. And he went, huh. And then did like a huge spiral motion, like a circle on the page, wrote something, and then tapped his pen, and then looked at me. And I was like,
oh my God.
Oh, I want to know what that says. I feel like I'm winning therapy. Like,
if we put you back in therapy right now, you might remember, because you've got to be in the same brain state.
When he never showed what it was. It might have been nothing. He might have literally just drawn a circle, scribble, tap, because it was like, he responds to this.
I'd love it if he just drawn like a big circle and then a little one inside it, and then a little one, and then a little label saying "snail?" ? And
then circle, small circle, booby, like just graffiti,
and then tapped it really hard, like Move it.
He was actually drawing a donut. It was just like snack after this.
Yeah,
snack. And anyway, last thing is. There was a study in 2012 where they studied the sequence of events that typically occur prior to and during the internalization of a false accusation in the courtroom.
False accusation is in you remember and when you're accusing someone.
As in, you, a lawyer, are trying to get your witness to get an opponent witness to remember something that didn't happen, and to try and build a case on false memory, basically.
Oh shit! Which presumably they're not intending to do, but there are certain techniques that seem to work. So,
I think it's more like you've been told this person is an eyewitness to the murder, and they turn up and be like, "Oh, I didn't see it," and you're like, "Are you sure you didn't see it?" In fact, I'm gonna do it to you right now, right?
Yeah, okay.
So first, okay, you say you didn't see the murder, but we know from security camera evidence that you were there at the time of when the incident took place, and you were in the alley.
Oh.
Now, you might think it may be possible that you have repressed this event because it was a fairly horrific crime, or otherwise, perhaps you were drunk, you've forgotten about it, but you were there.
Oh. Well, if Simon and I were there.
This is amazing. The next line in my thing is, at this point, the individual may make an admission of possible guilt using inferential language.
Oh no, is that what I did? I was just repeating what you
We got it, ladies and gentlemen.
No, I just said, well, if we were there. I didn't say we were there. I just implied we were there because you told me we were there. God damn it.
At this point, the admission of possible guilt may be aggressively pursued. So you were there, you admit to being there, and the suspect may begin to incorrectly create specific details of his or her involvement of the crime memory. You say you were there. You've admitted to us now in court. Can you tell us what you were wearing at the time of the event?
Yeah, so I was wearing a black dress.
That would make sense. You just come out of the club. Do you remember being there? And on we go. And then we're building up a whole...
This feels like a real nice psychic power that you're using. Like this...
It's like freaking Darren Brown shit. It's horrible, isn't it?
Yeah.
And is the point of what were you wearing about the fact that you're like combining real memories with...
Yeah, you can... I don't know exactly how you see that, but like it's the sort of... Basically, it doesn't matter. You're not looking for information from them because it's all fake anyway. You're just looking for them to remember stuff, which means they start making stuff up and then they just build their own little reality around it. It's dark shit. Do you want to end on something that's really dark?
Oh, good. We can go deeper.
Oh,
Excellent.
It's an alley stream. Welcome back, guys.
Well, okay. Let me preface this by saying, at first I thought this was really funny, but now I just think it's really horrible.
The Ali Jenny's guarantee.
Very scared.
just go whichever way you like. So they wanted to test them. A group of people wanted to test how like absurd you could make a false memory, basically. Like, can you make someone believe something completely ridiculous? So they asked, because they got 10-year-olds. So they did it with children, right? Because they're inherently slightly more malleable. And they got them to remember that they went on a hot air balloon ride. Okay. Which they didn't go on. Sad for them. Then they got them to remember that they had tea with Prince Charles. They didn't. And then they did the same to 6-year-olds to check which would be worse.
About being malleable, though. That's about not knowing how unlikely those events actually are, right?
You mean, I see what you're saying.
They don't know that them having tea with Prince Charles couldn't possibly have happened. Like it
wasn't like
to us
going to the moon.
I mean, 10-year-olds aren't 6-year-olds. They are like capable of knowing that.
I know, but like.
But that does correlate, right? Because you get kids who come in and just make shit up about what they did on the holidays, right? And that makes me wonder, like, have they actually convinced themselves that they've done this, rather than
that's the Boris Johnson effect, isn't it?
I'm not just going to make this up for clout. I really did go and have tea with Prince Charles. Or King Charles. RSVP, Elizabeth.
RSVP?
Oh, yeah.
You've misunderstood the situation here.
He's being silly.
I like the idea of saying RSVP now. That's a bit that's blurred across my brain from the Star Trek podcast, I've just realised.
Is that what I say?
I do want to ask Cass's question. Maybe it's not dark, which is it true that, she says, like, have you read that report that people forget how uncomfortable and painful giving birth is?
Oh, yeah.
In order to have a hormonal incentive to actually get pregnant again.
Well, that's interesting because that's partly about. I think I don't know. No, I've not. But also, I'm going to say something anyway. What's interesting about that is because you do get a bias, like a positive bias in memories often. That's like really? the rosy tinted specs looking back.
Named after rosy tinted.
Yeah, it's like the reason people voted Brexit, nostalgia. Like you get the nostalgia effect, and that is real. But it doesn't happen for everyone, right? And there's interesting work around like depression and how that affects your brain's ability to do that, or at least whether it chooses to do it. Anyway, but I don't know about the motherhood thing. But the other thing is, like, I'm just gonna put it out there. But at the point of so like the word for giving birth in Well, I learned about giving birth in one of my courses where lots of the work had been done on sheep. So they were like, yes, the hormones, they rise, they fall, like this, so sheep. And at the moment of parturition, and parturition is the word for when you're like, fucking everything opens up and out comes the baby, and it's grim as a word. Anyway, but you're on such a kind of like hormonal, you're in such an interesting hormonal place that the way your brain is probably in a state which only remembers the pain and that everything like there when it's in the same state again. Because and when you're back
memories work.
Yeah, you probably find it very difficult to...
a deliberate thing to try and like make people evolutionarily forget. It could just be a side effect of how memory works, and the fact that you need to be in a
But I mean, that's kind of useful anyway, isn't it? Like you can't go around your whole life being terrified of... Yeah. It's probably the same with, you know, being stabbed or something. Not the same thing.
Very cool. Very dark, this one.
It wasn't. It was... Remember all the stuff about the brain chemistry and
gaslight us when we were talking about fake memories.
I wanted to keep us in that lovely, sweet, like brain structure spot.
You know, you should have done a fake memory experiment on us.
Oh, that's the experiment we could have done all along.
Didn't you? You didn't.
Yeah, you could have been like, remember when I talked about, you know, the many tentacled parts of the brain, and we were like, yes.
Yeah, I would have said yes to that because I wasn't listening to all of that, and I'm sure
it would have been so good. Actually, I'd have needed to have like
mentioned because I remember tentacles being mentioned, and it went.
I'd have needed an internal collaborator, which would have been one of you two, and then we could have made the other one like that. It would have worked.
Oh,
next science chat.
We can do debates.
No.
Next science chat, we got to do something like that when there's something psychological.
Yeah, that's really good. If we can run an experiment on stream. Oh, that's such good. I fucked it. I fucked everyone.
Consent. I don't know. Probably not from each other.
Well, we'd have to sign away consent at the beginning, right? Not know what was going on.
Everybody cool with being part of psychological experiments on the RPGeeks Twitch channel?
Everything.
Right, we're both in. That's the majority.
Oh my gosh.
We have quorum.
Ooh, okay, right. Yes, we will end tonight there. Thank you so much, everyone who has joined us live, especially for all your questions and very intelligent discussion in chat. We love having a bunch of nerds to hang out with. Thank you all, YouTube viewers and podcast listeners. Put your own nerdy comments in the comment boxes, however they work.
Or on the Discord.
Oh, on the Discord. How, if someone's like listening to the podcast right now, how do they find our Discord? I just don't know how Discord works.
Do we include a link? I don't think we do actually include a link.
I think we do.
That's a really good question. I'm not sure how people find my Discord.
I'll tweet it right now.
Tweet it right now and just point them to the RPGeeks discussion page.
And
there's lots of other things that go on my Discord. If you like Warhammer, there's normally a lot of very good memes.
Memery. You are the meme king.
Oh, I'll get some good memes.
Should we do a Warhammer stream with the RPGeeks? Is that too far?
The new Space Marine game has a co-op campaign. I don't know if it'll run on your PC, but we could do the two of us doing that.
Yes, we got it! We'll run on my PC!
Do it.
We'll make it
work. Meanwhile...
This is a really good idea.
Meanwhile, we are excited to be back with episode 3 of the Absalom Files next Monday.
Should I bring in some music? Fuck. Just
like you kind of.
It's a bit late.
Not quite as
2 hours
now.
Into the
There's sort of discussion about it, is it? It's kind of a bit like, well, past the point. Like, do you want me to say it again, or
just vamp?
I'm still vamping while you find the music. Wow, this is gonna be so impactful when it finally comes on. Okay.
I've got no control over volume.
We're back with the next episode of the Absalom Files. It's a bit chill, but okay.
Oh, it's very chill. Okay.
Yeah, so it's calming and relaxing vibes, which is hopefully what our next session is going to be based on the cliffhanger ending to episode 2. Follow us on all the social medias at RPGeeksDND. Give us a shout, give us a follow, give us a like in various places. We have got a Patreon now as well. We're very excited about it. Thank you again to our patrons. We like you all. You're great. And we will see you next time.
Head bob out to outro.
Oh, yeah.
See you next week, everyone.
Oh, yeah.